excuse me, we had this one here. Now, remember guys, I've been harping on this thing pretty much nonstop. Whenever you're doing proofs, whenever you're doing that, please make sure you have your reason bank out as well as that progression sheet. Because if you don't have something on your progression sheet as we're going through it, now would be when we go through it, would be the time that we add to it, okay? I think as of right now, we've got, I think only 8 of them, right? Is that about right? I think everybody should have about 8 of them on there. Yes, sir?
Do you have another reason bank? I lost mine.
I don't think I have a copy. You'd have to just pull it up offline and print it.
Okay, they have one online?
I think I put it on the website. I'm pretty sure, yes, I'm pretty sure it's on the website or chapter 2.
All right.
Hey, at least they got here in time. Like your face. So the first thing that's given to us is that we have a bisector. What kind of a bisector is it, guys? Segment bisector. So according to our progression sheet, which we should have out at the same time, we need to go through what we know. AT bisects MH. That's given. According to our progression sheet, what do we do after we have a segment bisector? What does it say to do? Everybody should be looking at the progression sheet and answering that question. It says to do what? Segment equals segment. Now, can we do segment equal segment or segment congruent segment? Does it matter?
No, not.
Which one do you think we would do? Equal or congruent here?
Equal? Yeah, congruent.
Yeah, I would go with congruent because everything else is all written out in congruent. The reason that we have segment equal segment for this one, as well as midpoint says segment equal segment, they're interchangeable between segment equal segment or segment congruent segment. It's okay to do either one, all right? So if you want to put on your sheet or segment congruent segment, that's fine. That way you remember that. So the two segments that are formed, MT, TH, we write it down. MT, congruent, TH. Why, you may ask? What does your sheet say to do? Definition, segment, bisector. Ladies and gentlemen, the answers are all on the progression sheet. Yes, sir? It's a segment bisector. Remember, a segment bisector, a bisector can be anything. It can be a point, segment, ray, line, whatever. In this case, it's just called, it still runs into the midpoint of the segment, creates two congruent segments. But it's just called a segment bisector. Otherwise, I'd have to say T is a midpoint. But in this case, they're talking about AT. That's why we use that. You use what you're given. Is there anything else I can say about that? No, because according to our progression sheet, which I'm looking at, we don't see very many of them out. Come on. It says that's really all you can do. So then you go to the next statement. Yes, ma'am.
I had those two switched around.
That's okay. The only reason why I would not do that is because sometimes when you have multiple givens, you might forget that this was there. You know what I mean?
Oh, yeah.
That's all. There's nothing wrong with that. There's really nothing wrong with that. As long as you did get this definition segment bisector in there, you're fine. You'll notice that in some, on a lot of the fill-in-the-blank ones on this worksheet, they do that. Not my style of doing it. I like to make sure I get everything in right away, but it's all right. So we have these two statements. We have to prove that AT is congruent to TH, or excuse me, AT is congruent to MT. Do I have two things that both congruent to TH? So are they congruent to each other?
Yeah.
By what? What's the reason? What? We've used this thing a lot. Substitution. These two are both the same. These are the same. You only had to come up with one step here, guys. Everything else was on your progression sheet. If you could not figure out substitution after everything we've done since Tuesday, that's scary. It's going to be a very, very long semester for you. Okay? Really. Because over the course of the next 6-7 weeks or so, probably, the majority of the stuff we do will have a lot of proof to it. Okay? You have to become very proficient at looking up parts, looking at the relationship between things, going back and looking at previous work. Because as of right now, if you think about this worksheet that we have, we've done, what, 6 or 7 of them already together? That's 6 or 7 examples that you have in your hands right now of basically the same stuff. You have another 4 or 5 of them aside from that in your notes. You've got the 8 different progressions. You have all of the different reasons. It's a matter of looking at patterns, looking at what we've done in the past to try to see if you can figure out what you're doing with this stuff. The process for these things never change, guys. Just the letters. There's really only so many of these we're going to do. Okay? And then was the last one was the top of the next page, I think. Is that right?
Yeah.
Hey, looky here. This looks exactly like the one we did in class, where you had to add that middle angle. Remember that from yesterday?
Yeah.
You look at your notes when you tried to do this one?
Yeah.
That's the thing. You gotta be resourceful. Okay? You have to go back and forth a lot of times. So, as you start this one out, we are given the fact that you have angles 1 and 3 that are congruent to each other. So if you know that, looking at your diagram, what should you do right away? I mean, what should you do to your diagram?
Oh, you should put that.
Yeah, mark it. You know that these two are going to be the same. They want you to show that the larger angles are going to be the same. They want you to show this like that. Just by marking the diagram prior to reading what they were doing, you'll notice that both of those angles that are already equal to each other, they're adding in that middle wedge. Just like we did yesterday, we had to define that middle wedge. Gee, guess what they did here? They defined the middle wedge, added it to both sides. Oh boy, it's the same proof we did in class. You just didn't realize it. What's your first reason?
Given.
Given. Good. What changed from statement 1 to statement 2? Now they're equal. How do you change them from congruent to equal? What did you write down on your proof? Oh, the one you didn't do? 2 problems is a lot of work, isn't it? Correct. It's definition of congruent. Going to the next one. Why is angle 2 equal to angle 2? Why are you equal to yourself? Reflexive. Very good. You got that?
Yeah.
It's nice when you
But
get
I was
it.
really iffy on it. I was like, I don't feel like this is it.
You're right, you're right. It's nice when you get it right, 'cause you're like, yeah! Okay? Shut up. Now, look what happened here. What did they do here? What did they do? They added what? They added 2 on both sides, didn't they? Very good. Notice, here, they added 2 on both sides. When you add the same thing on both sides with equal sign, that's add prop equal. Just like we did with the algebra. Okay? Now, on your progression sheet, you probably have an example of what these next 2 are. These are, 5A, 5B. They're doing the exact same step. That's why they combined them together. Look what happens. Angle 1 plus angle 2 is the large angle. Angle 2 plus angle 3 is the large angle. Gee, what is that?
That's segment addition. Angle addition.
They would be angle addition. If it was segment 1 plus segment 2, yes, but now they're angles. And I'm glad you made that mistake though, because yeah, I know segments and angles, the addition property is the same thing. You just gotta make sure you write down the right one. That's all. Okay. So it's angle addition. Too small, add up to equal the larger. You wouldn't even need to know anything besides the fact that you see two angles added together and it equals another angle. That's pretty much a dead giveaway that that's what it is. All right, it's a dead giveaway. Take a big guess, bless you, what this one is. If it's reflexive, you would be yourself. That means that it would have said DEG equals DEG. What is it? No. It's substitution. Remember, guys, what these things are doing, they've all of a sudden they went from these two angles equal something here in here, but we've already stated that these two guys were the same. When two things are the same and they equal other things, the other things are also the same. Via dun, 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 substitution. And then last but not least, what do you got? Oh, what is it? Not equal, but congruent. Remember, we use definition of congruent to flip between equal and congruent or congruent to equal. Means the exact same thing to me. I'm fine with that. Okay? Means the same thing. Perfectly fine. Okay? May? All right, we got 3 progressions to look at. Let's try to keep those sheets out, and then we're going to finish that last one on the page there.
How's your day going, Mr. Murphy?
Not too terrible. Yours?
Okay.
We got our quizzes today.
Oh crap. I should be able to. Let me get through these real fast, okay? Because first hour I forgot to give them back because I'm really bad. I've been bad this week. I don't know why. But we had about 10 minutes to work on our homework, so I should be able to maybe get some of those out during that time. So I've got, I think, 3 progressions to walk through with you guys. The first one winds up being one of the most commonly used one, especially as we get into triangles. You will see it from time to time with segments and angles and things like that. But it's a progression that's going to allow you to say 2 other things. It's more of those compounded ones. We call it if given perpendicular. If we're given perpendicular. So if you're given perpendicular, just thinking about before we write anything down, what does that mean? What's created? There's no such thing as a perpendicular angle, but what kind of angles before? 2 right angles. Okay, now what do you know about 2 right angles then? They equal 90. And what do you know about angles that measure the same? Congruent, very good. So, you know poop. So what happens is, I read these lips and he's dropping the S-bomb around here and it's not.
Sorry, I made a mistake.
Oh, I
He didn't say, oh, she.
Did you say she talked mushrooms?
No. And I'm not going to try that one because I know I would mess that up really bad. So what happens a lot of times when you talk about perpendicular, there's going to be 2 things we're going to go through. First thing we do is we're going to state that right angles are formed and then we're going to say that right angles are congruent. Okay? How this is going to look is pretty easy. Okay? It's going to look really, really easy to write this out. My example. Let's say AB is perpendicular to CD. And I'm going to kind of draw the diagram off the side here. They're going to write this out a bunch of different ways sometimes. I'm just going to say this is A, B, C, and D. Let's make it look real generic. Excuse me. So, like I was saying, if that's given to us, if it says that AB is perpendicular to CD, it might already have a diagram. More often than not, you're going to have some sort of a diagram, something thrown in there. You rarely have to make these on your own. But if I'm looking at this, the first thing I'm going to do is state the right angles that are formed. So, what are the two right angles then that are formed here? So, we're saying that angles ABC and angles ABD are right angles. Does that make sense? We have to say that they're right angles first before we can say that the right angles are congruent. Okay? So why do you think my reason is that I can say that they're right angles? What have we been doing all every time with these? What's that reason going to be? Definition of what? What were we given? No, we weren't given right angles. What were we given? Perpendicular. So what do you think the reason's going to be? That's it. Definition of perpendicular tells you that you've got right angles that are formed. That's all it is. If you go through all of your progressions, guys, if you're given complementary, our reason after that was definition of complementary. Supplementary, definition of supplementary. Linear pair, definition of linear pair. Supplementary, definition of supplementary. I don't know, segmented, bisector, definition of segment bisector. Midpoint, definition of midpoint. It's the same thing over and over again. You're given on the left, whatever statement that is usually your reason after you state it. Okay? Now that you have two right angles, what we're going to do then is this. Angles ABC is congruent to angle ABD. Because I put these little boxes in there. And the reason that those two right angles are congruent to one another is basically this. All right angles congruent. And that's your reason. Those are the sequence of events that you would go through as you're writing out something that's perpendicular. You would say that you have the right angles first. After you say that you have the right angles, then you just say that the right angles are congruent. Not terrible, is it? Not at all. An offshoot of this is when we have just right angles. Okay. We'll put it. Are we all?
No.
Okay. I'll wait. Sometimes I go too fast. I get it. It's good times.
Make it awkward.
Are they always with their tongue?
Just trying to be cool with the emphasis on the word try.
What?
Never mind.
I heard that.
Offshoot of perpendicular. Sometimes you're just given right angles. Sometimes it might just say that, hey, angle 1 is a right angle. Sometimes it might say that 2 angles are right angles. It could be a couple of different things. So I'm going to put in 2 different versions of this. If you're given that you have right angles, then you're just going to state, one of the things you can do is state, if you have 2 angles, we'll state that right angle congruent to right angle. Basically that means if in a proof it says that angles 1 and 2 are right angles, I would say that angle 1 is congruent to angle 2. Does that make sense? But sometimes they'll just say that angle B is a right angle, and they're just going to have just one angle. If that's the case, 9 times out of 10, you're probably just going to have to say that angle B equals 90 degrees. Because you're probably going to do some sort of angle addition or work with complementary, something along those lines. So if you're given the fact that you have 2 angles, so if you have 2 angles, you say that they're congruent to one another. If you have 1 angle, thanks. Actually, I keep my water. What?
I'm gonna put a dinner like all messed up.
Wait, what?
So it's not fun. It's like I can't.
It is funny.
It's like I have no control over my tongue or anything right now. So I'm going through a lot. Y'all think it's fun?
Yes, we do. I just love the fact that she comes and goes, I'm sorry, I can't follow back. So if you have 1 angle, just say that it's equal to 90, okay? That's kind of what we're looking at. So, that proof, like I said, if it's given that angle 1 and angle 2 are right angles, if it says something like that in the given statement, that angle 1 and angle 2 are both right angles, then your statement would be angle 1 is congruent to angle 2, and my reason would be all right angles are congruent. Remember, if it's saying that all right angles are congruent, if it says angle 1 is equal to, if you write angle 1 is equal to angle 2, because maybe in the problem they're talking about angle addition at some point in time, that's okay. Then you can switch that to saying all right angles are equal, depending upon the problem. Sometimes it works, it'll work either way. It's not a big deal. Okay? And then the other version of that would have been angle B is a right angle. If that's given, then you can say angle B equals 90. What do you think my reason for that would be then? Take a guess. Did I just say definition of right angle? You're on the right track. If this is the case when you just have to say that it equals 90 degrees, go ahead and use definition right angle. Okay? Does that make sense?
Yeah.
There's one other that we'll get for you. It's perpendicular. It's pretty easy. The last one I want to show you guys then today is one that you might not see very often with segments and the angles that we're looking at as of right now, but it will show up a boatload of times in triangles. Okay? And that's when we talk about what are called vertical angles. Do you guys remember what vertical angles were? What was it? Yeah.
Oh no, I was
You had your arms moving. I thought you
Well,
knew.
yeah, because like vertical, so I was like, do it with my arm, because my arm.
What were vertical angles then? You have it. Show your arms again. Yeah. You had what Louis has with his arms went like this. Remember, vertical angles are the ones when lines cross. Whenever lines cross, I'm sorry, I'm being a jerk, but it's funny. Remember, when you have vertical angles, Anytime two lines cross, two segments cross, how many angles are formed?
4.
4 of them are. No matter what, you're always going to get 4 angles. Here's the thing though, within these 4 angles, if this one is 100, oops. If this one is 125 degrees, what does this one here have to be because it creates a line?
55.
If this one's 55, what does this one here have to be because it creates a line? If this one's 125, since it creates a line, what does this one have to be? So basically what happens here, guys, is that no matter what, the most you can get for when two lines intersect are 2 different angle measurements. Okay? They're repeated across from one another. Vertical angles are ones that are opposite each other, go in the other direction, above, left or right, up and down, or sideways, whatever. Those 2 will always be congruent, and those 2 would always be congruent. They always, always, always will be. So what we do in terms of a progression for this is that sometimes you're going to have vertical angles. And I say, look for vertical angles. Look for vertical angles. Vertical angles are generally something that will not be given to you. It's going to be one of those things that you're going to be able to imply from a diagram. Remember how we had those problems earlier, our A, B, and C's collinear, things like that. Vertical angles are the type of things that you're going to see within diagrams that you're going to be able to state. If you look at the worksheet I gave you with the proof stuff, if you look over real quick on page 2, if you look at page 2 real fast, and I'm going to show you guys what's going to happen here soon. If I look at, excuse me, if I look at this diagram on the very top, if I look at the diagram on the top, what do you know about 1 and 2? They're not right angles, but what do you know about them? They're equal to each other because they're vertical. I could say somewhere in my proof that angles 1 and angle 2 are congruent to one another because all vertical angles are congruent. It's not given to you in a generic sense of a given statement, but it is something that you're going to be able to imply from a diagram. So it's not going to be something that you say, hey, blah, 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 and blah, blah, blah are vertical. You're going to be able to take it from a diagram. Is that okay? It's one of the few things that you can take from a diagram to make it work. So what I say then is look for, yes, sir? This is just point C. That's all it is. It says, because it's saying that C is the midpoint of AD. So if C is the midpoint of AD, you get AC and CD equal to each other. And then here it says that B is congruent to E. And they want to show that those 2 triangles are congruent. Well, eventually we can say that because with all that information along with that vertical angles, we have angle, angle, side, which is a way to prove the triangles are congruent. We'll get there in a couple of weeks. So again, look for vertical angles. What I want to do here is have you guys put a diagram just like this in there. And we're going to do this as angle 1 and angle 2. And just do that. You want to take things, go grab some. That's fine. Does anybody have a bid? We should make a bid.
I know.
I'm so what? Have you yeah, it works.
Oh, that's
I'm something. Creative really isn't one of them. Crazy? I'll go with that.
That's not nice.
She's getting it. This is keep fun.
This is
You gotta write full bit on
Can I go to the bathroom when she comes back?
Doesn't it? Hey, it's not that crappy.
She's back.
She's back.
Don't let her insult me.
Mrs. Murphy, can I go to the bathroom?
We made you a bid.
I'm fucking very.
It's like a
You
crime.
gotta like figure out.
I absolutely love my job. That's weird. All right. So anyway, what I would say here then, if I had a diagram that looked something like that, or like we did a second ago with the when we had the those triangles that I showed you, what'll happen is that you'll be able to take that inference from a diagram, no problem, and you'll be able to write down angle 1 congruent to angle 2. And the reason behind this is always going to be the same. Vertical angles are congruent, okay? Like I said, it's not something that's going to show up a ton over the course of these next week or so, but it is really, really important when we get to a little bit of the few proofs that we do in chapter 3, and then big time in chapter 4, okay?
I saw what you did.
I appreciate you being a sport. It's just funny.
How long does it last? Like, when you get somebody in here been to the dentist and got a number shot before?
Oh, yeah.
And how long does it last? Cause it's like
Few hours.
a few hours.
Try not to. You don't want to like chew food because you might bite off your tongue.
Yeah,
Yeah, don't try and chew on your lip or with your tongue or anything. Don't try to do that. Because when it'll be gone by the time.
Oh yeah, people do that and then they lose their tongue.
Yeah.
And the dentist he told me that.
Jada. It lasts a while.
What hour's your lunch?
10.
You'll be alright.
Oh, yeah. Maybe.
My last few days.
Just make sure you have someone eating near you in case they start seeing blood flying all over the place. That way they can save you. I'm so messing with you. I'm so messing with you.
Oh my God. I was
My dad tried to tell me that when I got my teeth pulled out.
Yeah.
That's next week. I gotta go get my wisdom tooth pulled next week. What y'all think I'm gonna do then?
Yeah. Don't come back to school after that one.
Yeah, don't come back to
Okay. Last one on the worksheet, very back page, bottom part. This one is where we put together perpendiculars, complementaries, a whole lot of substitution going on. And then I will let you guys loose with some homework. I know, it's very exciting. Last one on the back page. So, as we go through this one, once again, once again, these guys have a tendency of putting their given statements together. I don't like it, but whatever, it's what they did. So they wrote in here right away that BD is perpendicular BA, and 2 and 3 are complementary. So we are given. Now, in the back of my mind, with those 2 given statements, yes, sir. Back page.
I know.
It's like the only one we haven't done yet.
No, I know, I just forgot my sheet.
Gotcha. So in this case here, what they're doing is they're starting out by working with the perpendicular portion. So they're saying that angle ABD is a right angle. Well, ABD is a right angle because of the definition of perpendicular. Okay. Now they're skipping ahead and they're not saying anything else about that, which is fine. They're skipping back to the complementary. They said that 2 and 3 are complementary, so why do angles 2 and 3 add up to equal 90? Because of what? Definition of complementary. Very good. See, I gave you a compliment on that. Okay, definition of complementary angles. Now, excuse me. Why does angle 2, or take a stab of why angle 2 plus angle 1 plus angle 2 equal another angle? What do you think that means?
Angle addition.
Angle addition. Angle plus angle equals angle generally is going to be angle addition. If you have no idea what you're doing and you see that, you should always get that right. Yes, sir?
Did you say angle addition again?
Angle addition again.
Ha ha.
This is cool when you say it. It sounded cool.
Can you spell it?
All right. Now, here's the one thing I didn't like about this, because they keep switching back and forth a little bit here. If it was me, I would have said that angle ABD equaled 90 a couple of steps ago, because we had ABD as a right angle, definition perpendicular. So why does equal 90? Because it's a right angle, because of the definition of right angle. Okay? Now, why do angles 1 and 2 have to equal 90? Because of what? Hold on. Look at where we have. Where do you have angles 1 and 2 represented, or ABD represented before? We have ABD here, here, and here. We have 1 and 2 here. Hey, 1 and 2 is an ABD. ABD is a 90. Substitution. Again, whoops. The reason why I can go ahead and use the substitution here is because I have 1 and 2 here, 1 and 2 here. Well, 1 and 2 is 90, 1 and 2 is ABD. Where's ABD? Oh, ABD is here, it's also 90, so that's also got to be 90. That's what I'm doing. I'm using substitution. I'm trying to see what else is equal to ABD. What else is equal to 90? Okay. So what else in this whole statement side is equal to 90 degrees? Angle 2 and angle 3. So anywhere I see 90 degrees, I can replace it with an angle 2 and angle 3 by using substitution. Substitution again. What happened between the next step?
Simplify.
No, very good. Subtraction, property equal. The 2's dropped out. Sub T, prop equal. And last but not least. Good, very good.
Definition of congruency.
Way to bring up the back there.
Echo chamber.
Okay? So, these are the things that we worked through. What I want you guys to do this weekend, though, is flip to the very front page. On the front page, there are 10 statements. There are 10 statements here. Excuse me, 10 givens, if you want to think of it that way. What I want you to do is figure out, well, if angle 1 equals angle 2, and angle 1 equals angle 3, what could I say from that? Angle 2 equals angle 3. Why? What's your reason? Very good. Basically what I want you guys to do is I want you to, well, now do 9 of them. Your best way of doing these, draw the picture of what it might look like, go off of your progression sheet and or your reason bank. You should be able to get all those without a problem. I do recommend drawing pictures though. It does help because some of this stuff is very, very visual. Do those last 9. We'll go check them on Monday, and then we'll start doing proofs that you have to start completely on your own. Okay?
Sí.
Que bueno. Que bueno. De nada. Let me load this and probably wait a minute. Give me a sec.